everybody, and welcome to the booth of Linear Technology. You are on the booth of the leading provider of battery stack monitoring solutions. And I'm Jackie Rutter, and the Linear Technology team welcomes you to the launch of the first ever wireless battery management system in a BMW i3 car. How cool is that? Wait, the best is still to come. Wait. So this unique wireless battery management concept car represents a significant breakthrough that provides and offers a wide range of benefits that will be presented to you right now by our expert panel. We have Mr. David Qualls, Executive Officer and Vice President of Linear Technology. We have Eric Soul, Vice President of Signal Conditioning Solutions and General Manager for Linear Technology. And together, we are here with our partners, Mr. Daniel Quinger, CEO of LionSmart. And with the owner of Chrysler Electric, Mr. Marcus Crazel. We are going to be presenting the benefits of this concept car. For the next 20 minutes, you will hear the best. Afterwards, we will have a question and answer session. So if you just lift your hand, we have several ladies with microphones. So just as if you're singing, you just hold it up so everybody can hear you. Please enjoy the champagne and enjoy the canapes. Let us rock.
All right, can you hear me? So Jackie, I don't know if I qualify as an expert, but I appreciate the kind words. So I'm Dave Quarles. So I'm Linear's VP. I'm Linear's VP of International Sales, and I'm here to explain how this crazy idea of a wireless BMS concept car was born. And the whole idea of wireless BMS, or communicating wirelessly in a BMS, that's nothing new. We've actually been talking about that internally at Linear for quite some time. But that was the problem. We were just talking about it. And so earlier this year, in April, I was at the Hanover Fair, the industrial fair, and at the end of the fair, I went to Daniel and said, and we share the same initials too, both DQs, which is pretty neat. And I said, fellow DQ, do you think by electronica you could build us a prototype wireless BMS system that would sit on the table and we could prove that it works? So instead of just talking about it, let's prove it. And Daniel said, if you want to prove that it works, you need to put it in a car. So it's kind of cool and vogue these days where everybody in Silicon Valley is making a car. So we said, why not? Let's join the party. So after some discussion about what car to use and the technical challenges and some pre-work, we officially kicked off the project in early July. So what's amazing about this, in 4 short months, we've gone from talking and a concept to this, a car that actually works and it actually drives. So I think this is an excellent example of German engineering, but they also showed the speed and agility of what we see in Silicon Valley. So I'll turn it over now to Eric Soul, and he's going to explain some of the benefits of this revolutionary technology.
Good afternoon. My name is Thank you so much for coming today. This is a very exciting day for us. I'm responsible for both the development teams that do the high voltage battery stack monitors here at Linear Technology, as well as all the wireless technologies. And today we're going to show you really a tour de force of engineering. We combined those technologies and we also added it to a car that has 55 kilowatt hours energy and over 430 kilometers of range. And we're going to talk about how we did that and what are some of the interesting benefits. Before I get started, I'd like to introduce a little bit about battery management systems so you can understand a little bit what we're talking about today. And here you see a picture on the screen of a cross-section of an i3 and the battery pack removed. And you can see that there's some small boards there. And those are to represent how the boards and the electronics are physically placed in the car. And what we're measuring here is parameters such as voltage and current and temperature. And those are all vital parameters that need to be monitored by the system as well as understood by the driver of the car. So you know how much range, or if you have a fault condition, maybe the state of the health of your battery. So just to give you a little bit about background with Linear in high voltage battery systems, is we really are the market leader in this area. We have by far the highest precision data acquisition system that you can put in any vehicle today. We have a safety critical architecture that is fully compliant with the worldwide safety standards and can achieve the highest automotive safety integrity levels. We also really have the most experience. We've been at this for over 10 years now. And we just introduced the LTC6811, which is our 4th generation battery monitor. And worldwide, we have shipped over 20 million units in this area, so we have significant market share leadership. Let's talk about some of the goals of the battery management system. There's really 4. This is a mission critical function in the car, and as such, safety is the absolute most important thing. But along with that, it has to be smart, it has to be green, and it has to be cheap. I don't like that word cheap. However, what we're showing today is really a breakthrough concept in this area, which uses our smart mesh wireless technology, which is commonly used in industrial applications and is deployed worldwide in over 50,000 wireless sensor networks, primarily in areas such as industrial process control and other very harsh environments. This is very different technology than wireless that you might think of that is commonly used with Bluetooth or Zigbee. This is an industrial grade, highly reliable wireless mesh. So what we've done in this car is we've replaced those wired boards with wireless nodes. And these nodes communicate through a multipath or meshed network. We call that smart mesh. And we think this architecture has the potential to make the car even safer, even smarter, even greener, and even cheaper. I want to go through each one of these areas and really illustrate what the key benefits are so you understand what I'm talking about today. In the area of safety, the single most common point of failure in a car is wires and connectors. And because this is a mission critical function in the car and the batteries always have to be monitored, any break will put you on the side of the road, or worse, if you miss a critical fault, it could lead to some type of a hazardous situation. Let's take a look at the wireless system. We now have multiple paths, multiple communication paths, and we have a manager that understands the quality of service or the integrity of all of those paths. You may have a case where there's some type of a blocker or interferer. So what happens? The manager knows the quality of service of all the links and automatically reroutes the traffic information around the fault. We've done this with 5 nines reliability. It's tested and guaranteed, and that is built into our network. This is very different than a typical software stack where you develop your own network. This has been tested over a variety of configurations for 5 nines with telecom grade reliability. And Another advantage is that it's end-to-end secure. It's AES 128-bit encrypted, and there's authentication technology that goes into this. So the chance of having a low-cost, counterfeit type of module entering the network is very difficult to achieve that. Let's take a look about the smarts in the system. Because you have this wireless mesh, or this wireless canopy over your battery management system, it's much simpler to add additional sources of information or nodes. So adding sensors for temperature, for current, is much easier to add to this type of an approach. Another advantage is that in a typical wired system, your data is coming back asynchronously or non-time deterministic relative to voltage and current and temperature. Well, it turns out that the wireless sensor network has a very accurate sense of time, and every node knows within microseconds relative to the other nodes. And that allows you a really interesting advantage. It allows you to time synchronize voltage, current, and temperature. And when you're calculating your state of charge and your state of health, it turns out that synchronizing these parameters is extremely important and was previously very, very difficult to do. Let's talk about the environmental impacts. You know, typically, in a car, if you look at all of the communication buses within a battery management system, it's a physically large system. There could be, quite commonly, up to 10 meters of wire in all of those connectors. So in a typical car, that's 10 meters and a half kilo of weight. It may not sound like a lot, but if you actually have to produce that and install that over a typical series run car, that can add up to 50,000 cars produced, 500 kilometers worth of wire and 25,000 kilos of weight. So it's a significant amount of material that's being produced. Let's take a look at the cost now. Typically, when you assemble one of these packs, there are a lot of wires to route and connectors to plug in. It takes significant time to validate that and install that on a production line. Obviously, that can be avoided with wireless configuration. Another important thing here is also you want to be on a roadmap that drives your costs down over time. Because you're replacing copper and wire and connectors, which are continuously increasing over time, with silicon, which is decreasing over time, you're getting on a cost curve that is going to give you advantages over the next several years. So in summary, I hope you can appreciate that we believe this is really a revolutionary concept. This is not a small change in this industry. It has some major advantages. It's also really cool. And what we did here is we decided to go build it. And in the process of doing that, and doing the safety analysis, and doing the security audits, and just driving it around, we proved that it's working, that it's safe, and that it's secure. So with that, the next steps are that we're going to actually put together a full evaluation kit. We're already working with lead customers right now, and we can discuss that if that's something of interest to you. But we really want to put an evaluation system in your hand, and we hope to have that by early next year. So, thank you very much for your time. At this point, I'm going to turn it over to Daniel Quinger, who is the CEO of our valuable partner in this, LionSmart.
Thank you, Eric. First of all, I want to thank our partners, Linear, for making this possible, and also Presse for their battery technology. So, to make something like this possible, you need two things. You need managers who are willing to make a decision quickly and free up a budget, and you need a great team which is able to do this in such a short notice of a time. So please, one applause for the managers and for the team who made this possible. So I want to elaborate on two things. So the first is open battery management systems. So we started working together with Linear more than 6 years ago on open source battery management, and we have great support from these guys because they share the same vision. Similar to the cell phone industry, where we have started with gazillions of different operating systems, we believe that we need an operating system standard in the industry. And as we were a battery prototyper, we always had to buy the battery management system systems, and we had huge issues with them. So we said, hey, why don't we make it like a Linux for batteries, where everybody can contribute? Because really it's a big waste of engineer talent that we have hundreds of BMSs out there, and everybody is doing their own SOC algorithm, balancing algorithms. It will help to improve the speed of development, because we couldn't rely anymore in electric mobility on a 6-year development process, because the underlying technology, the batteries, are developing so fast that we have to adapt to development cycles from the consumer electronic world. And this is why we went with an open battery management system. And I really want to invite also other BMS manufacturers to join in and contribute to the open platform. So where do we stand at the moment with the BMS? So we have built in this car the latest generation of our BMS system. We have a wireless slave, which is controlling the 10 modules the battery consists of. We use always the latest linear technology chips, and also on the master side, we have used our latest master and have adapted to the dust smart mesh IP network. What are the next steps? The next steps are that we also want to have a dust-enabled current sensor, and also in the future maybe get rid of the CAN bus connected to the car at all, and have the whole battery system talk wirelessly to the car or to the charging stations or to other parts of the system. Maybe I would say 2 or 3 words what we have done here. So we engineered a battery in the original space where the regular i3 battery sits. So we didn't fill up the trunk or something in this car. We used the original space of this car, and thanks to the Presse-Event laser welding technology, we were able to cram in 55 kilowatt hours of battery capacity, also because we freed up space where normally it would be used for cables. It's a liquid-cooled system which can be fast charged in 15 minutes to 80% of its capacity. And as you see from the pictures, we still got some space left. So if we would have more time, I think we would easily have crammed in there 70 kilowatt hours. This is only achievable if you work with really good guys, if you use the latest technology, and if you're willing to have an open mind and are not stuck to old things like I have to have a canvas or something. When you are open up your mind and see all the possibilities new technologies bring, and you really put them to use, here you can see what can be achieved. Okay, that's it, and I want to give over to Markus Preisel. I really want to thank him. They are also a very good business partner of ours. We work on almost any project we have with Preisel together, and I think they will have also a bright future, and that's your turn.
Thank you very much for your nice speech to me. I think I have to do that. I want to introduce myself. I'm Markus Preisel. I'm the owner and CEO of Chrysler Electric. And we did here for the BMI3, the battery models inside. So they give us the balance market and the engineering of this technology, and we did for them the battery assembly. And I want to say something about our company. We are focused on cylindrical cells, so there's a lot of discussion because how to respect the cylindrical cells. Our technology is based on cylindrical cells. We have a very patented system regarding welding technology and thermal management. We have a cooling solution, a very special cooling solution where each battery is surrounded with a special liquid, so it's very efficient. And the most people and companies always speaking about cooling. I think cooling is not the most important thing. I think heating, also heating batteries is very important. because everyone needs or wants to have a car charged within 15 minutes. So that it's possible to charge a car within 15 minutes. You need a battery temperature around 30 degrees, but you do not destroy the battery too much. So it's also an active system where every cell is surrounded with liquid, so it's very, very efficient. And very special is obviously speaking about price and reduce costs. We can introduce very fast and very cheap full automatically our technology. So we can assist here with very cheap production and assembly line technology. And now I want to show you something about the battery. You can see the original picture. The right side is the original battery from the i3, and the left side is the already now built up battery. We have put in 55 kilowatt hour capacity that could reach a range of about 420 kilometers. It's amazing, I would say, with such a car. Of course, the i3 is very efficient, so very good 55 kilowatt hour to reach this. And very important is the charging time. So it's possible to charge this car within 18 minutes, up to 80%, because of the special thermal management inside the battery. And of course, the Wireless-BMS von Linear Technology, perfect. It makes it very easy to build up subscription. It's very easy for also for assembly line technology to integrate this. It's perfect. Okay, that's it, and thank you very much. And if you have questions, please ask me.
So thank you very much. I'm going to now open the question and answers session. We have two lovely ladies with microphones. So could you please hold up your hand if you have a question, and they will go to you. So could you, up there to the first one, thank you.
Three questions. First, for the battery. Who takes the warranty? I don't know if the BMW takes the warranty for this car itself. Secondly, what is the frequency used for this mesh? 2.4 gigahertz, 5 gigahertz, frequency. What is the range of this mesh network?
Oh, okay. So, first question regarding the warranty. Obviously, this is a concept. So, warranty is a much very complicated subject, and really provide the underlying technology. Who handles the warranty is really between the customer and the manufacturer. So, we really don't have a direct answer on that. You asked about the frequency. It is a 2.4 gigahertz based. However, it is very different than a lot of other technologies that use the same band, in that it's time synchronized and it's channel hopping. And it actually communicates extremely well, even in the presence of a lot of other 2.4 gigahertz. In fact, with the hundreds of wireless networks that are going on in this room right now, it operates with 5 nines of reliability. I don't remember what the third question was. The range of the wireless. So the wireless indoors is several hundred meters. Outdoors, longer than that. Obviously, we're in a small constrained space. Being a battery pack, range is really not an issue.
Further questions?
What markets do you see adopting this technology classically? Do you think it will be China first, or Europe, or the United States? What's your sense of market adoption?
We actually have some lead customers. Right now that are all around the globe. Like I mentioned, you can provide some economies of scale. We believe that wireless can be significantly cheaper. So on the mechanical side, on the battery side. Maybe we use them.
Yes, because we did a lot of sampling technology, and if you use EMS,
So obviously that's a big topic, and it's going to evolve over time. Right now, there's a surprisingly minimal amount of security in a car. Of course, with wireless, everybody is even more paranoid. So, you know, this network, really the security is built into the network. So within that battery management system, it's an end-to-end security solution, and it's really extremely difficult to break into that, and it's using to monitor very expensive assets like refineries. So that trust has already been placed in there. Now when you go beyond this and you start to talk about what you're describing as other wireless sensor networks in the car, it's a much more complicated issue, and that's really outside the scope of what we're talking about today, but it's absolutely, we think security is become an even more and more important issue.
Further questions over there? Yes.
Are you integrating any active balancing in the system?
No, we didn't include active balancing because we believe that active balancing is something which is useful for really large battery installations where there's a lot of energy transfer in a small application like in a car, especially when you use many parallel connections. Statistics help you in having very equal capacities throughout the cell, and it's just cost prohibitive to use active balancing because we want to have a system as cost competitive as possible, and active balancing in a car doesn't make really sense from the economic point of view unless you use really bad cells.
Right, well, thank you very much for coming to the launch. I would like to thank our expert panel. I think they've been pretty good. For those of you, we've got a press pack, printed copies, and also a memory stick inside. You can get those in the reception. And even better, we've got the mini version, the miniature version of the i3. So you can get those also in the